There are a couple of ways to look at the proof on the test for Section 5, for Learning Target 5.8. So I've put two ways of doing the proof on this video. Doesn't mean these are the only two, these are just the most likely two that people would have done. Now what I said was, there's a lot of notation on this figure that you don't necessarily have to use. So it depends on which way you decided to attack this, which of these labeled angles and such you used. It says it wants me to show, so the thing I need to prove is that angle PDQ is congruent to angle QRP. That's always going to be the last thing on the right. So I can go ahead and put that in. Well, the only way I'm going to be able to show that those two angles are congruent to each other, because I'm not allowed to use the parallelogram opposite angles conjecture, since it's what I'm trying to prove, the only other way that I have to prove those two angles are congruent is to use CPCTC. Well, I can't use CPCTC, which means corresponding parts of congruent triangles are congruent, unless I have these two triangles congruent to each other. So my statement before that, and I'll come back to the reason in just a minute, is going to be that triangle QDP is congruent to triangle PRQ. The only way I can get congruent triangles is to bring in three congruencies prior to that. Two sides in an angle in a specific order, two angles in a side, or three sides. So these are going to be these three statements. Well, I know, looking at that figure, that this side, which is segment QP, has to be congruent to itself. So that's this part. Notice there's no arrow leading into this statement. I don't need to know anything prior to being able to say that a segment is congruent to itself because it's the same segment. So there isn't anything leading into it, only leading out from it. There are people who started here with their proof. They said, well, I know that segment DP is congruent to segment QR, and the reason that I know that is because of the parallelogram opposite sides conjecture. Likewise, I know that segment DQ and segment PR are congruent because of the parallelogram opposite sides conjecture, but they started their proof there. The problem is that the parallelogram opposite sides conjecture says if a figure is a parallelogram, then the opposite sides are congruent. So I can't say this unless I have the if part proven prior to that. And that's that it's a parallelogram. And also, you should always, 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 always use your given in your proof. So I can't use the parallelogram opposite side conjecture unless I have first demonstrated that I'm working with a parallelogram. So first I'm working with a parallelogram that's given. Because it's a parallelogram, which is why these arrows are going where they're going, because it's a parallelogram, I'm able to say these two sides are congruent using this conjecture. And I'm able to say these two sides are congruent using this conjecture. And then I'm able to say, not because of that, but just because it's the same segment, that QP is congruent to QP. So I end up with this segment congruent to itself, I have this side congruent to this side, and I have this side congruent to this side. So for this one, the reason that those two triangles are congruent is because of side, side, side. Now, another way to get that was, again, we're trying to prove that those two angles are congruent. The only way to do that is to use CPCTC. So again, we have to have the congruent triangles prior to that. Now, we're going to start with our given. It's a parallelogram, and that's given. And there's always a reason below the box. Because it's a parallelogram, the definition of a parallelogram says that the opposite sides are parallel. Now, let's look at this, and I'm going to highlight a little bit. Because side DP is parallel to side QR, and I have this transversal, what I'm looking at is angle 3 is congruent to angle 6. So, angle 3 is congruent to angle 6 because they are alternate interior angles. And it says if two parallel lines are cut by a transversal, then alternate interior angles are congruent, which is why the arrow goes, if this, the arrow goes to the then. So angle 3 is congruent to angle 6. Now, let's go back and look at the next set. Transversal is going to be the same, but in this case, if this side is parallel to this side, and this is my transversal between those two sides, then I end up with angle 2 and angle 4 being formed by those. Those are my alternate interior angles that are congruent. I don't get 3 and 6 and 2 and 4 from the same set of parallel lines. Now, I still have, QP is congruent to itself. So in this case, I end up with an angle-side-angle congruence instead of a side-side-side. But again, the arrows mean the box before it is my if and pointing to the box that's my then. If it's a parallelogram, then I can say this because of the definition of a parallelogram. And if those sides are parallel, then I can say these two angles are congruent because of alternate interior angles conjecture. And these three things together are required. If I know all three of these things, then I can say that these two angles are congruent.